Alright, so I got myself a new switch for the reverse light. If you're not familiar with switches, you could configure them a bunch of different ways. And in this case, you can see normal state, device is not on, light is not on. You press the button, which it's latching, then the device will go on and the LED will go on. You could do it other ways where the light's always on, whether it's off or on. And you could also do it to where it's opposite, where the device is off and the light is on, and then the device is on and the light is off. In my case, I'm going to go for this first one. That way it reminds me that I got to turn that light off. So hopefully that will work, and go ahead and configure this up. Alright, so this could get a little tricky when you're thinking about it. The way these switches are built, and it's hard to see in this diagram, and I keep missing it because it's not visually kind of there, is there's a red wire here that blends in with the casing color, so it's hard to see, but your black is your negative, your red is your positive, and that's actually for the LED in the switch itself. Okay? So if you connect those two, your light's going to be always on no matter what. And then in this scenario, when you're looking at the diagram, your blue is normally open when the switch is off, and your yellow is closed. So you can see up here it says NC or NO, right? Normally closed, normally open. So in this scenario, you're seeing that we're actually switching the positive across the blue. So you put a positive voltage here, and then when you push the switch in, number 4 turns on and completes the circuit and turns on the light bulb. However, in automotive, you're not switching the positives, you're switching the negatives. So now you're thinking, well, okay, if I'm switching the negatives, in other words, and I want normally open, so that means negative is going to be going through the blue, then how do I get my light switch to turn on? Well, it's simple. You don't connect the black to the actual negative of the car. You connect the black over to output 4, because in my case, my LEDs already have a positive connected to it from somewhere else, directly to the battery. And so all we're going to do is switch on the negative. Well, that's also true for the LED. So you put this input to negative, and then you tie these two together, and when you push the switch, the negative completes the circuit, and therefore you can see I got blue and black tied together, and I got the other blue going to negative, and the positive is hot at all times, and so now I hit the button and that completes the circuit. So all I have to do is attach that to my LEDs, and that will complete the circuit and ground everything out. And the yellows, you don't do anything because that's a whole different circuit that we're not using. So having one of these little DC power supplies on a bench really helps troubleshooting and figuring stuff out and designing before you take it to the car and you try to figure out what's going on. But I've had this thing since, like, it's been in the family since the 80s or 70s, maybe even longer. So it still works, and works great for these situations. Alright, so now see the LED up there? Got it turning on, red light, turn off. So everything's working as planned. So I got the temperature gauge working. I just had the engine on, turned it off, and we're at 150 degrees is what the computer's saying too. So we're all good to go on that one. So got everything working, reverse lights and the temperature gauge. This thing, I think we're probably as good as it gets, because I know I've adjusted that multiple times and that's the best I could do. So all good.